All right, so we are classifying real numbers. Here is one of the foldables that you may have seen. All right, so we're going to start from the top and work our way down, just because I think that you may understand it a little better. Sometimes you start from the bottom and work your way up, but we're just going to start from the top and work our way down. So we're going to start with irrational numbers. I'm going to open my flap. I already wrote everything out for you. All positive and negative, non-terminating, non-repeating decimals. Okay, these cannot be rational, integer, whole, or natural. Cannot be rational, integer, whole, or natural. So non-terminating, non-repeating decimals. Okay, let's put some examples of irrational numbers. I'm going to pull our calculator just so you can see for yourself what these look like. So the first irrational number that many of you have probably heard before is pi. It's pi. There it is right there on the calculator. So if I hit shift and I hit that, this is a decimal. It doesn't end, even though it ends on the calculator. That's just because the calculator ran out of room. And it doesn't repeat. 1, 4, 1, 5, 9, 2, 6, 5, 4. There's no pattern. So this is an example of an irrational number. So you can just make the pi symbol. Okay. Which is the same as 3.1415 ... Okay, it just keeps going. Another irrational number, when you start to deal with roots, if I hit 2 in the square root, 1.4142135562. Well, it's non-terminating decimal. It's not repeating, so the square root of 2 would be an irrational number. All right, let's try another number. Square root. Let's try the cube root. So let's put in 9. Shift. All right, 0.80083823. There's no pattern. This is the cube root of 9. Those are some examples of irrational numbers. All right? Remember, these numbers are non-terminating, non-repeating decimals. They cannot be rewritten. And if you want to put exactly like some of the numbers that it might equal, so 1.414 ... means it continues. We're not rounding, we're just putting what it equals. 9, shift, cube root. This is 2.0800 ... It keeps going. All right, rational numbers are done. I'm sorry, irrational numbers are done. Okay? You know irrational numbers. These numbers that we're about to talk about now, they can never be an irrational number. A irrational number can never be one of these, and these numbers could never be irrational. Let's talk about rational numbers. And I'm just going to hide this. Okay, let's talk about rational numbers. Rational numbers are all positive and negative fractions and decimals, both terminating and repeating, that can be written in the form of a fraction, A over B. All right, so rational numbers are numbers that can be written in the form of a fraction. Okay, first thing I'm thinking of, or also a decimal. Okay, a decimal that terminates. So the first thing I'm going to think of is 0.1. That's a decimal. It terminates. I feel comfortable with that. a fraction. A lot of people like to go with half. Okay? Half is the same as 0.5. Alright, that terminates. A lot of people don't think of it, but even with the square roots, I can do square root of 4, which is the same as 2, which is the same as 2 over 1. And then I have something like 3 squared, which is the same as 9, which is the same as 9 over 1. I also have ones like 1/3, which is the same as 0.333. It keeps going, but I can write that because I keep seeing the 3's as 0.3 repeating. Put a line over it. So there's lots of rational numbers. So now let's look at some of these pieces. We already know that fractions and decimals are rational numbers. Now let's talk about the other pieces. Let's break this down some more. Okay? The other types of rational numbers that we see in here. Let me give you one more. Negative 32. It can also be written as negative 32 over 1. I'm going to give you one more. Negative 4 over 2 is the same as negative 2. Alright, so lots of them. Alright, let's look at our next piece. Integers. All positive and negative real whole numbers. Okay? Goes from negative infinity. Examples are negative 3, negative 2, negative 1, 0, 1, 2, 3, all the way to positive infinity, as long as they're whole. Alright? So let's write some examples of those. Alright? So I already had like negative 2 from my rational numbers. I had negative 32. I had 9. I had 2. So we can think of some more. Any whole positive or negative number. I also can use 0. Negative 7, 13, and you could keep going. Alright? So it goes from negative infinity to positive infinity, whole numbers. Alright, next, we're going to talk about whole numbers. All positive real counting numbers, including 0. So it starts at 0. So 0, 1, 2, 3 goes all the way to infinity. Goes all the way to infinity. Alright, so some whole numbers that we used before were 2, 9, 13, 0, and then you could think of some more. 100, 3,271. Alright? Next is natural numbers. All positive real counting numbers except 0. So it starts at 1 instead of 0. 1, 2, 3, and it goes all the way to infinity. So I can use those numbers I had before. 2, 9, 13, 100, 3,271, 1,000,001. I can use all of those. Alright? Please recognize that these are all rational numbers, and they cannot be irrational. Rational numbers, integers, whole numbers, natural, cannot be irrational, And irrational numbers cannot be rational. If you have any questions, please feel free to leave a comment. Or if you have any suggestions, also feel free to leave a comment. Thank you.